Note number 6. If R is perpendicular to F1, then can deduce that F1 plus F2 cosine theta equals 0. Same if R perpendicular to F2, then F2 plus F1 cosine theta equals 0. Next, we are going to find the resultant of several forces. The resultant of several forces. If we have several forces, we must deal with the coordinate system, which is x-axis and y-axis. And this is at the same time the directions west, north, east, south. The positive direction of x-axis, which is east, is the initial side of the all angles. So it is 0 degree. And when move in this direction, which is counterclockwise, is a positive direction. And when move in direction clockwise, is the negative direction. In this case, our challenge here to determine each force and its angle, which makes with the positive direction of x-axis. So if we have here F1, then we have F1 in polar form equals F, its magnitude, F1, and its angle is 0. And also if we have another force, F2, and it makes theta 2, in this case F2 equals the magnitude of F2 and theta 2 in its polar form. F3 then F3 in polar form equals its magnitude and 90 degree. Now we have 3 forces. So these forces is are more than 2 forces. So they are several forces. Okay? If the forces more than 2 forces, we deal with them as the same steps, at these steps. F4. Then this is theta 4. From the positive direction of x-axis to the force and move counterclockwise. So we have F4 in its polar form, F4 and theta 4. F5. So this is theta 5. Or negative this angle. They are same. So now we have F5 on its polar form f5 and theta 5. Blah, blah, blah. After this step, what can we do? We will convert all these forces only onto two forces, and these two forces will be perpendicular. How come? I find their components, the sum of their components in the direction of x-axis or the components of x-axis, and these components with x-axis will be cosines. So f1 cosine 0 plus f2 cosine theta 2 plus f3 cosine 90 plus f4 cosine theta 4, blah, 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 and so on. Fy, same, but instead of cosine, we use sine. So f1 sine 0 plus f2 sine theta 2 plus f3 sine 90 plus f4 sine theta 4, blah, blah, blah. After this, we can find R as a polar form also. If we put fx, comma, fy, okay, equal polar fx, fy, that gives us the magnitude of the resultant and its inclination to the positive direction of x-axis. Manually, the magnitude of the resultant will be square root fx squared plus fy squared. And theta equals fy over fx. But in this case, you must concentrate with fy and fx to determine the quadrant we are going to deal. If fy is negative and fx is negative, so this is the third quadrant. So we must find tan theta, you get positive, and then in this case, the theta equals 180 plus shift tan fy over fx. Okay? Notes بقى. Of course, this notes is very important notes. Number one. If the resultant acts in positive x-axis, that means theta equals 0 and fy equals 0. Number two, if the resultant acts in negative x-axis, then theta equals 180 and fy equals 0. And in the two cases, the resultant equals fx, but here resultant equal absolute fx because in this case, fx will be negative. Same scenario, but with yx. If the resultant acts in positive direction of yx, then theta equals 90 degree, and fx equals 0, and r equals f1. Number 4, if the resultant acts in negative direction of yx, then theta equals negative 90 or 270, and fx equals 0, and r equals absolute f1. The magnitude of the resultant equals absolute f1.